Lesson 2, factoring trinomials of the general form, and in this lesson a will not be 1. Okay, so for this one you can put a not 1. We've done the a equals 1 already. Now you won't be using algebra tiles, but I will just give you a quick demonstration of this. So the algebra tiles here are represented by the expression 2x squared plus 7x plus 6. And the whole point of the algebra tiles is to arrange them into a rectangle, because a rectangle can be expressed as a length multiplied by a width, which we understand to be the area of a rectangle. Now how are we going to arrange these rectangle or these shapes into a rectangle? So there's a special property involving the 2 and the 6. When you multiply the 2 and the 6, that's the AC value. That's 12. And then there's also this special property with the B value being 7. What is the special property here that we need? We need to find an arrangement of the rectangles, or pardon me, of the shapes, so that we can form a rectangle that has these dimensions with 12 and 7. So what two numbers multiply to 12 and add to 7? You know this one, you've done it. The two numbers are 3 and 4, right? These are the two numbers. So that means you're going to need to split up these rectangles here into two groups, 3 and 4. Okay, so let me show you how to construct this. So you have the two squares. You have the two squares, and then we can line up 3 vertically. And then the other 4, we're going to split up into two sections like this. And that leaves exactly room for how many of those smaller ones? 6. So yesterday I showed you guys just a grid that would do the same thing. So these two guys in green, those are 2x squares. These two, or these 3 rectangles represent 3 x's. They're also like terms with these guys down here, so I'll just keep them in blue. There's 4x there. And then the last but not the least is the 6 units down in the corner. There's 6 here. So if you're asked to find the length and the width, what's the length here? 2x plus 3. Because the length of the square is 1x, so it's 1x plus 1x is 2x plus 3. And this way it's x plus 2. So those are the length and width factors, x plus 2 and 2x plus 3. But that's not how I taught you guys how to do it yesterday, was it? How did I teach you guys how to do it yesterday? The way that always works. So let's show you the way that always works. 2x squared plus 7x plus 6. This method is called decomposition because you decompose the middle term. What did we change the 7 into? 3 and 4. Now look ahead. Would you rather have the 3 go with the 6 or the 2? Yeah, I think you'd rather have the 4 go with the 2 and the 3 go with the 6. In the sense that in the next step, you're going to buddy them up into partners. So I think you'd rather have 3 go with 6 and 4 go with 2. Ultimately, it doesn't matter. You can put 3 first and then 4, but I think this will just be a little bit smoother. And remember, what do you want to take out of each pair? Yeah, very nice. A GCF. So in the first pair, you could take out a 2x because they both divide by 2 and they both have 1x in common. So when you divide that 2x out of each, you have to open up a bracket with space for 2 terms. And in your mind's eye, imagine dividing those 2 terms up above by that common factor 2x. You end up with x plus 2. In the second one, you want to take out only a positive 3 because they have no x's in common. Dividing by 3 on each of those, you get x plus 2. Now you notice they have the x plus 2 in common. Okay, and there it is. Okay, so the reason that we decompose the trinomial's middle term, 7x, into 4x and 3x is so that we can get 4 terms in the expansion. Because remember, when you FOIL something, how many terms do you get? You get 4. So x goes on to 2x. That makes 2x squared. X goes on to 3. That makes these 3x here. 2 goes on to 2x. That's 4x here. And 2 goes on to 3. That's 6 right there. So the length times the width is a binomial times a binomial, and they fill 4 spaces in the grid. So we won't use algetiles. I don't think people enjoy algetiles. There won't be algetiles on the test, I promise you. So how do you know which 2 numbers to use when you're breaking down the middle term? Right, you got to do a little bit of brainstorming. So remember, you need the AC value. What's the AC value? 5 times 2. So we need 2 numbers that are going to multiply to 10, and then they're going to add up to positive 7. Guys, can you just be quiet, please? Okay, so again, for your brainstorming step, you need 2 numbers that multiply to 10 and 2 numbers that add to 7. What that pattern will give you is the ability to form that rectangle. And if you can't find 2 numbers that do this, then you can't form the rectangle, and then therefore you can't factor it. So not all of these work, but most of the time they do, because you're given ones that work. So 5 and 2, they multiply to 10 and they add to 7. And it's just a coincidence that 5 and 2 are also in the equation. It's just, that's not always going to happen. It's just a coincidence. So then we can break down that middle term. You leave the front, you leave the back, and you just break down the middle. 7 x's, you're going to split into 5 x's and 2 x's. Then you put them in partners, but the 5 goes with the 5. But ultimately it won't matter. Ultimately it won't matter. Out of the first pair, you can have a common factor of 5 as well as a common factor of x. When you divide that 5x from each term, and I'm just going to jot this down so people can see it. This is what you're doing in your head. So what would you be left with? X plus 1. Now I'm going to erase that because you have to do that in your mind. because otherwise it just gets really messy and you won't know what's going on. So you get x plus 1. The other thing is, how do you know you've done that properly? Well, just double check in your mind. If you put that back in, would you get back up here? Okay? That's just a check for you mentally. Now, out of the second pair, you could take out a 2, and you're left with x plus 1. Now they have the x plus 1 factor in common, which can be factored out. And then again, in your mind's eye, it's like, okay, this factor's been removed. What's left over? Okay, the 5x and the 2. So again, this is the length times the width. This is the area of a rectangle. The area of the rectangle has those 4 terms in a grid. That area of the rectangle. Ultimately, if you can just understand that, then you're good to go. But really, most of this stuff is just procedural. And in in 30-2, you often don't even get these ones with the a value not 1. You usually get the easier ones where a is 1 in the 30 level. So it's quite nice. You guys don't have to get... anyways. So now this is the decomposition method that the book wants us to do. It's the same stuff as... So we already did these ones. So let's go to class example 4. So for the first one, and what you can do is just on the side here, I would really urge you to draw this in like this. What that allows you to do is have some structure. Remember, you have to do 6 and a -3, which makes -18 when you make product there. You have to times those, AC. And the B value is 17. So you have to think of some magic numbers. So I'm going to have to ask you to stop yelling those out. It's not that it's just hard for other people to think about it, right? So when those two terms, these two over here, and this one's a hint, what happens if they're just off by 1? Don't forget that any number can be multiplied by 1 to get itself. But this factor over here is -18. So which one of those factors, not Olivia or Zach, which one of those factors should be negative? Good, the 1. And that will allow the sum to remain positive. So you want the bigger number to remain positive. So those two numbers in blue, I use them to break down the middle term. That decomposition step. You keep the front, you keep the back. The 17x changes to positive 18x and a -1x. Okay, I encourage you to include the sign, including a 1. Okay, no problem, I'll post for you. Also, be really mindful of patterns. Like if you look at the sign patterns, plus, plus, and then minus, minus. You actually need that pattern to be the same. So if it's plus, plus, these ones need to be plus, plus. So I'm going to have to factor out a negative. Factoring out negatives switches sign. In the first pair, you take out a 6x, 6. And again, another good strategy for this, when you have them in pairs, just check the low number. Does 6 divide 18? Oh, then that's the GCF, because that's the biggest number that will divide 6. If 6 doesn't divide 18, then go lower. Maybe 5, maybe 4, maybe 3, and so on. It's never going to be bigger than your smallest number. Anyways, take out a 6x, and you get x plus 3. This is really a good thing. You can see x plus 3. This is almost identical, except it's minus x minus 3. So I just need to do a small little trick when you take out that minus 1. Okay, and you have 6x minus 1 as a factor and x plus 3 as a factor. You okay with that? Yeah, not really a trick, just what you have to do, yeah. Sometimes though sometimes you have to take out a positive one. Like, yeah. So that can be a little bit weird too though, because it's not entirely obvious to everybody. Anyways, you guys okay with those notes? I can move on? Okay. Okay, same idea with the brainstorm step. Two numbers that multiply to negative 24. Two numbers that add up to negative 2. I'll pause the video. Please don't. Alright, so it's 6 and 4, and then you just have to decide which one of those is going to be negative or positive. Because if the product is negative, one has to be positive and the other has to be negative. Yeah, the one that's bigger, because it ends up negative. So those are the two. Break down that middle term. Keep the front, keep the back. Those minus 2x's are minus 6x's plus 4x's. Okay, take a look at the pattern for the sign. It goes plus minus, plus minus. Oh, it's perfect. They're perfectly aligned. You're not going to have to factor out a negative on this one. What did I forget to jot down? Very nice. I forgot that little 2. So now, out of that first pair, what could you take out? Check the small number. Does 3 divide 6? So that's it. So you got 3x coming out, and you're left with x minus 2. Is there any way you're going to be able to scale down those other two factors to get x minus 2? What would you have to divide those by to get to 2? You have to divide that 8 by yeah, so you got to take out a positive 4. Now, a lot of people will do this, and it's not entirely wrong, but it's not perfect. A math person might get uneasy about this. What am I missing there? Yeah, you should really be careful. Just because it's positive, usually you can omit them, but I really encourage you to put that plus sign right there. Because it's not a product yet. It's a sum of two terms, and those two terms have a common factor, which is x minus 2. It can be factored out, and you get 3x plus 4. So some people that were away yesterday, feeling okay about this? Because the people that were here yesterday, this is just like double dipping. We are hitting up this lesson twice. All right, two special numbers that multiply to 12. Two special numbers that add to negative 8. I'll pause and you can think. Trust you. All right, so what were those magic numbers here? 12 and 1? No. 3 and 4? No. So it's got to be 6 and 2? Ah, very good. Was that? Ah, good man over there. Good man. So, yeah, because the product is positive, but yet the sum is negative. So they got to both be negative. Good work back there. So you keep the front, you keep the back, and the middle gets changed to these special numbers. These are t's this time, so we have a negative 6t, negative 2t. Remember to put little hooks on your t's, curl them up so they don't look like plus signs. And now take a look at the pattern. It goes plus minus, minus plus. So what are we going to have to do with that second term? Yeah, factor out a negative. Alright, so let's factor out negative out of that second one. Let's just change it up. Do the second one first. Okay. So we're going to need a 2t minus 1. How do you get 12 to look like a 2? Divide by... You're going to have to take out what on the first two? How do you make a 12 look like a 2? Yeah, you got to take out a 6. And we have to also remove one factor of t. So the first pair, what are you going to take out? 6t. And you get 2t minus 1. Sometimes students will mess up the one where, like, see how it's 6t and 6t? when they're identical. Sometimes students put 0 there. That's bad. You got to put a 1 for a placeholder. Because when you divide by yourself, you get 1. 5 groups of 5. How many in each group? 1. Okay, so now take out the common binomial, 2t minus 1, and you're left with 6t minus 1. Those are the factors. Okay, class example 5. These are the two examples where they're just trying to really play tricks on you. The first one is in the wrong order. And also A is negative. So there's two things there that would bug me. It's in the wrong order and the A is negative. I hate that. In the second one, they have a common factor in the beginning. So these are two examples where they try to mess with you. You know your strategy, you know your technique, but what if they throw a twist? Can you adjust and adapt and not freak out and shut down? Yeah. Definitely just rearrange them. So let's do that first. Rearrange. And it's important when you rearrange to just keep the sign. The 2x squared is negative, keep it. The 7x is negative, keep it. And the 15's positive, keep it. Why? Well, because like in general, a plus b is the same as b plus a. So it doesn't matter what order you add them in. As long as you keep, like, if this was negative a, then you have to keep this as a negative. Okay, so the other thing I really despise is the negative on the x squared term. So I'm going to factor out a negative 1. What happens when you factor out negative 1? Only the sign changes. The numerical value does not. So you get 2x squared plus 7x minus 15. Now I'll just factor that thing. So now I'm like, okay, two special numbers that add up or multiply to negative 30, and two special numbers that add up to 7. Okay, I'll pause. You can think. All right, so it's 10 and 3. Which one's going to be negative? Yeah, the 3, because you want the larger one to win in the addition to end up positive 7. All right, so break down that middle. Leave the minus on the outside. Keep the front, keep the back. Sometimes students get a little bit messed up with all the brackets that are going to come up, but it's kind of like those Russian dolls where there's a doll inside of a doll. It's kind of like Inception, a dream within a dream. You have to spin that top to make sure you know you're in the right reality. You ever see Inception? So those 7x's are you're going to change to 10x's, take away 3x's. Take a look at the pattern. How does it go? Yeah, plus plus, minus minus. So you're going to have to factor minus out of the second group. Out of the first pair, what you taking? Yeah. 2x. Good. What's left over? X and a 5. Good. Now you see those nested brackets. Hopefully you're okay with that. Coming out of the second pair, what do you see? Negative 3. I heard it. Good. You get x plus 5. Close the bracket on the x plus 5. Close the bracket on the outside negative. Now on the inside, what factor would be factored out? The x plus 5. And then left over is the 2x minus 3. So a negative a value, this quadratic equation, this graph would open down. You would have a maximum value. All the other y values would be below it. What would the x-intercept be here? Yeah, negative 5. And I wonder how many you could find the x-intercept for that one. That's actually Monday's lesson, but we can try it right now. What if the 2 wasn't there? What would it be? If the 2 wasn't there, what would it be? Positive 3. And then to get rid of the 2, you just divide by 2. So it would be positive 3 halves, which is positive 1.5. Good, Olivia. You guys okay on that one? A lot of brackets, but you could try factoring it without taking out the negative, but I think so. The other thing you could do is just, you got to take out a negative, factor that thing on the side, and then you have it factored normal, and then just remember to throw on the negative at the end. Okay, second one. This one is hard for students because sometimes, especially with times tables, people don't always know that there's a common factor. So you might just jump right into this. You're like, oh, 15 and 10 is 150. I need two numbers, go to 150 and add to 5. But what you could do is just take out a GCF first. What's in common here? A 5. And only a 5. Because there's no x here, you can't take out an x. X is not in common for all three. So you can only take out a 5. You're left with 3x squared plus x minus 2. This one I'm going to guess and check on. Remember, I told you sometimes it's easy to guess and check. If the front number is prime, is 3 a prime? So you know there's only one way to get to 3. It's 3 times 1. The other thing that's nice is there's only one way to get to 2. 2 times 1. So this can be a 2 and a 1, or this can be a 1 and a 2, but there's also a plus and minus, could be like this. So you could actually guess and check this one. What's the middle term? Plus 1. So I'd want to put a plus 1 here and a minus 2 here. Can you see why? Foil that out. You get 3x squared plus 3x minus 2x. That gives this. And then minus 2. If you had the 2 over here, then you'd go 3x times 2. That's 6x. And then you'd have only a 1 here. And that's too far away from this. So I guess and check there. You do not have to guess and check. Yeah. So I have the ability to guess and check. You guys, go through the method. Like, I'm just showing you another strategy, but go through the method. Definitely. Okay, anyways, let's move on. Oh, assignment. Okay, so that's it. 45 minutes to work. I'll give you a quiz as well.